So now that we've finished going through Java Executor Service and some of the executor framework stuff, you should have enough information to do the programming assignment 2A. Now let's go ahead and start focusing on the next set of topics which you'll need to do assignment 2B. And this will involve discussing something called the Java ReentrantLock. So I'll first start by talking about the concept of mutual exclusion. I've hinted at this before, but I'll show you some more detailed analysis of this. And then we'll break this stuff up into other parts that'll talk about reentrant locks and so on. So mutual exclusion, which is sometimes referred to a mutex, so a mutual exclusion lock, which is often called a mutex for mutual exclusion, is used to define something called a critical section. And you can read more about critical section here. Critical section is basically a chunk of code where you only want one thread to be executing at a time, because you're accessing some shared state, some often shared mutable state, and you don't want the threads to corrupt it. So we use a mutex to make sure only one thread can execute this code in the critical section. And it does this by essentially acquiring the mutex, which lets it enter into the critical section. So think about like a room with a door. So as long as the door is locked, you can't go in. Once the door is unlocked, you can acquire the lock. That will then, when you are inside, it locks the door again so nobody else can get in. You can then go ahead and do your thing, accessing whatever shared mutable state you need to. You're running. Any other threads that come along that want access to the critical section have to follow the protocol, and the protocol is they have to acquire that lock, and they darn well better be following that protocol, otherwise chaos and insanity will break out. So in a sense, the mutex and the protocol for managing this thing ensure that other threads are kept at bay so they don't corrupt the mutable shared state or the resources. And the reason we're trying to do this, of course, is we want to avoid race conditions. If multiple threads were in this critical section at the same time, then chaos and insanity would break out. We could end up with changes to the state that would be inconsistent, and that would lead to this race condition problem, which can arise when a program depends on the sequence or the timing of the threads, the order in which they run, or when they run, to operate properly. After the thread that's in the critical section is finished, it will go ahead and leave the critical section. So it does that by releasing the lock. So it's kind of like it's exiting out the back door. And at that point, some other thread, whoever happens to be next, and next could be FIFO, next could be non-FIFO, but whatever the right acquire order is, will then let a new thread in. The other threads will continue to wait, and this new thread will do its thing in the critical section. Notice, by the way, and I think I'll talk about this later, that this protocol is fully bracketed. So the thread that's in the critical section is the one that releases it. So the thread that acquires the lock must be the one to release it. OK, so as we've seen before, a mutex is typically implemented in hardware using atomic operations. And remember, atomic just means they appear to occur instantaneously, and they appear to other threads in the process to either have happened all in one fell swoop or not to have happened at all. And we talked about lots of examples like transporters and other things that were examples of this. Under the hood, this is implemented by the compare and swap methods we've talked about before. And I think I've also mentioned the human known use, but we'll go through it in a little bit more detail. So a human known use of a mutual exclusion lock is an airplane restroom protocol. So if you've ever flown an airplane and had to use the restroom, you're undoubtedly familiar with this. So here's how it works. You want to use the restroom. You wait until the sign says vacant, in which case you can walk in the door. You then shut the door and push the little latch to the side, and then that changes the state to occupied. Anybody else who comes along who wants to use the restroom has to wait. When you're done, you unlock the door and leave, and then another person can come in. So this is fully bracketed. The person who locks the door must be the same person who unlocks the door. OK, so that's the quick end of what is a mutex. Hopefully that is just review at this point, because we've talked about these things a little earlier in our overview of synchronization.